Yes, yes, yes.
Sì,
Perfect.
sì, sì, si vede.
Thank you very much. So, hello everybody. I am Francesca D'Agresti, sorry. I am Francesca D'Agresti, researcher and developer at Engineering Informatica. That is a digital transformation company in Italy, also expanding in its global footprint all over the world. The group I belong to is focused on innovation through our research and innovation group. Our division that comprises researchers and data scientists. In particular, today, I would like to give you an overall view about the data storytelling and the big data analysis, and how, in particular, how to manage data regarding natural disasters and the approach adopted in the TEMA project, on behalf of which I am participating today to this e-course. So, first of all, what is big data? Big data is defined as the technological paradigm that allows researchers to conduct an efficient analysis of vast quantities of data that is made available through the current practices. So is we can say that is the collection of scientific and engineering methods and tools that help in making, we can say, the best choice, the best methods, and in order to choose the best of the massive amount of data available. So big data also addresses the not only storage issues, but also issues related to accessibility, related to distribution, analysis, and also effective visual presentation of data, of course. So in the domain of disaster management, we can say that the cycle comprises four distinct phases, which are mitigation, preparedness, also response, and recovery. First of all, the goal of the mitigation phase is to minimize the effects of a disaster, and in order to have a long-term risk assessment and reduction. The main focus of the preparedness phase is on basically on planning on how to respond to a disaster. Response activities pertain to providing the required disaster management services in order to save lives and protect the environment during the disaster management situations. So the recovery is instead the process of, we can say, the returning systems to normal levels after a disaster. So what we want to focus on is understanding how the emergency technological topics associated with leveraging the ecosystem of big data can be useful for monitor and detect these natural hazards and mitigate their effects in order to, at the end, contribute to the recovery and to the reconstruction processes. According to the World Meteorological Organization, the number of weather, climate, and water extremes are increasing and will become more frequent and severe in many parts of the world, of course, as a result of climate change. So, while the number of disasters has increased by more or less a factor of five, deaths from disaster have decreased by a factor of three. And this is due to an increase in early warnings and thanks to the improvement in disaster management. But how this big data can help in emergency situation? First of all, we know that technology has helped in the case of many natural disasters, such as the disaster that occurs in Haiti or in Nairobi. And in these cases, the existence of open source platforms and even social media has been fundamental in saving human lives. And in particular, social media and software platforms provide services that allows us to stay connected with also with our families during the time of natural disasters. In case we cannot be in person together. So, and in many other cases, of course. We need to be also prepared for emergency situations. And for example, this means that citizens share information that can be life-saving, such as the presence, for example, of family members that have physical problems inside the household and so on. So these are only some examples on how the technologies and software platform can help in this situation. And how big data and data storytelling approach is connected. So first of all, we need to understand what the problem is, because we have to provide the policymakers, the citizens, with the information in order to deal with with the disaster. So we need to start collecting data in order to create, first of all, a data catalog. This data catalog is basically a set of data, a set of open data that can be then analyzed to extract useful information to create then the policy. But also, I think that is important organizing co-creation sessions with all the people involved in the disaster. I mean that the first responders, the citizens, the policy makers. So a session of co-creation involves we can think about more or less a round table in this sense. So in a co-creation session, the problems affecting the policy to be created are studied, are discussed, and also analyzed. So all this knowledge coming from those sessions and all the data collected must be saved in this sense, and so that can be part of the raw data to be analyzed among also other data coming from different data sources. At the end, the possibility of produce visualization and dashboards. These dashboards we can say that tells the story described by the data. So at the end, the data became information having a business value. So. In particular, what are then the technologies involved in big data for natural disaster management in our specific case? So when disaster happen, rescuers can use real-time satellite imagery to see what's happening on the ground and find people in need of assistance, for example. For instance, this could be the case, but also meteorologists, meanwhile, can use satellite images to spot disasters as they are forming. So, if they see, for example, early signs of a tropical storm or, for example, smoke from an active volcano, they can issue preemptive warnings so that people can evacuate, for example, in prevention. And also, we know that artificial intelligence can help make sense of these views from space, no? Of course. So using deep learning. And the computer vision, we can identify the areas that are vulnerable to extreme weather, and to recognize everything from cloud formations, and categorize also the all these heap of data, so that the weather services can respond easily. Following these events in real time, because we need to remind that all these events must be recognized in real time. So the AI software, of course, continually analyzes these images, and then pairs these images with their sensor data and weather prediction in case, in order to see the areas at risk of floods, for example, or fires, so that local government can, of course, issue early warnings to the citizens. And we can say also that drones survey the scene because, for example, in 2005, in the case of Hurricane Katrina, this hurricane devastated part of the Louisiana and Mississippi, and immediately, in this case, emergency responders deployed for the first time to drones during this natural disaster, and to search for tripped survivors. And at the end, after some hours, they determined that there were no one was trapped, basically. So drone can help in these cases, of course, and can be equipped also with sensors, with some, for example, meteorological stations. And in the natural disaster management, in this cause of a disaster, what responders needs most, but often lack, is current is inaccurate information. So in this case, social media can may be the key to get it. For example, by extracting data of natural disasters from these social media posts, software tool can detect and track weather hazards, and, for example, determine from whom the information is coming, and can be a person affected by the disaster, can be a government official, or an emergency responder, and so on. And at the end, we can say that while drones and tweets can provide critical information during and after a disaster, the Internet of Things, the IoT, can provide very critical information before a disaster. Because, for example, water level monitoring sensor can catch the early signs of flooding in rivers and or in streams. And while sensor measure air quality can immediately detect dangerous levels of pollutant or chemicals or I don't know, smoke, radiation, and so on. So, as an application in the natural disaster management domain, is interesting, I think, to talk about the TEMA project, which is also the work on behalf of which I am presenting today and I am participating today. So, this is a research project. Founded by the European Commission and started 2 years ago, more or less, which aims to provide methods for exploiting data and knowledge for extremely precise outcomes. So basically, starting from data from satellite images acquired by drones that are launched in correspondence with areas where natural emergencies such as fire in particular and floods can occur. Then we can say that, yeah, I can say that the project involves many partners who are for us, sorry, who are key partners in the fields of data analysis, of AI modeling, of drone technologies, but also cloud computing and policy and also public bodies. Basically, Tema will be want to be an AI-enabled and natural disaster management platform, and which will be validated and demonstrated into basically into important cases. Forest fires and floods. So, thema visualization will be interactive, will be intuitive, and accessible. That is very important, and will also allow human operators to understand complex natural disaster management phenomena and in order to easily evaluate alternative response strategies. And Tema will provide also a scalable and efficient NDM analytics as a service. In order to make the advanced analytics tools available on the cloud. So, the platform, basically the platform adopted by the project for the management of the big data and to, first of all, allow the integration of all the different components involved in the project is the Digital Enabler. Digital Enabler is a data platform developed by my company, by engineering, and adopted in several projects. Basically, the Digital Enabler is a data management ecosystem platform enabling a new data economy business model, leveraging a complete suite of accelerator. What are these accelerators? So accelerators cover all the phases of data management, starting from data discovery to data collection, then from the data integration to data analysis and management. So basically, the platform allows to define a data catalog related to the ecosystem we want to create, and draw on heterogeneous data coming from very different data sources, exploiting big data and AI, considering of course, the security aspects. This engineering ecosystem platform basically allows to discover, to integrate, and also to harmonize and visualize different and multi-source data. This platform can represent a single point of knowledge for our data and for the cities, for example. In this slide is graphically we can graphically see all the phases of the data management cycle, life cycle, and all the functionalities covered by the digital enabler at each level. We can see the data source connection, device management, the IoT management, data management, integration, and so on. In particular, the digital enabler ecosystem is currently adopted by the TEMA project for natural disaster management, and the aspect of the digital enabler that we will focus on mainly concerns the aspect of the data management. In these slides, in particular, we can see a very high level architecture of the adopted in TEMA, in which we basically have, we can say, a chain of components and also AI softwares that basically subscribe to a given component, so to some given components in order to be informed as soon as it provides it data, so that the disinterested components can use this data in order to produce other further analysis. The first element of data management that is part of the digital enabler is the Fireware Orion Context Broker. First of all, Fireware Foundation is basically drives the definition of the key open standards that enable the development of portable and interoperable smart solutions in a faster and easy way. Leveraging these Fireware's core capabilities, it is possible to cities can be transformed in platforms, in digital twins for the publication of context data. But what is this context data? Basically, context data includes information from different and disparate sources. In particular, within the Fireware platform, an entity represents the state of a physical or a conceptual object which exists in the real world. For example, a street is a real world public thoroughfare, but is existing in a built environment. The context data of that entity defines the state of that real world object in this sense at a given moment in time. So we can represent everything in our context broker. Here we have added some examples such as a street, trucks, and citizen claim, for example. And each entity have and is described by its properties. Then we can say that through the Fireware architecture, basically, it is possible to manage the data in a standardized way that is very important for interoperability aspect using standard APIs, in particular the ETSI NGSILT standard API. This is exactly the standard API for managed context information. So the Etsy NGSILD API is a simple but at the same time powerful public and royalty-free standard API for managed context information. Is simple because basically it's a set of RESTful APIs, which we know that any programmer can learn very easily them, and is at the same time is very powerful because it supports several functionalities, the possibility to perform queries, geo queries on data, the possibility to manage linked data through the usage of JSON LD, and we will see later during my presentation something about it, and also many functionalities such as subscription, notification, and as we can see in this image, basically an external third-party application, an external service can very easily get this context information that is inside an instance of a context broker. So the context broker, by using the NGSILD API, provides the access to data and therefore to the real world data that is contained, that the context broker contains and that it represents. So NGSILD API serves, yeah, is usually referred to context brokers that are associated to an endpoint, a public endpoint. So we can say that the context broker provide access directly to data through this set of APIs. The context broker contains that content information that is a set of entities, as I said, and these entities represent a certain piece of the real world, we can say. This is why we can say that these entities are digital twins of real objects. For example, real people or real objects in the world. In this example, for example, we can see that the context broker contains the entities that represent the world of an hospital. So we have one of more doctors, one or more patients, of course, surgery rooms, and so on. Each entity is uniquely identified with an ID and also with a set of attributes. That is, that are the properties that characterize the entities. But what is exactly this NGSILD? This next generation service interface linked data is currently adopted in more than 35 smart cities, and there are also many fireware partners that are supporting this NGSILD standard, such as Red Hat, such as Atos, Telefonica, and so on. And this is the open standard for context information management that has been developed to facilitate the exchange of information between different applications that are using context information in the specifically in IoT. And why we are talking about JSON LD? We know that JSON is the data exchange format, no? But in some cases, it's not so easy also for machine and for people to read it. But because the attribute of a JSON can have a different meaning, for this reason, it was defined a JSON extension in which it is possible to annotate a piece of JSON with additional information. Basically, JSON, for example, we have a JSON with an attribute name, for example, no? For a person, this name could be the native name, but for another could be the stage name or the username. So it's not so clear in some cases. So for this reason, JSON, this extension, in this extension, the attributes became URIs, so that the meaning is clearer and therefore is easier for people and machines to understand it, no? And how we are using the JSON LD in managing context broker. Basically, in the description of entities and their attributes. Basically, an entity is described by its type that serves as a representation in order to categorize the entity. The entity type defines its unique characteristics and its unique properties. The attributes, so an entity can have one or more attributes. That is a set of properties for the entity that characterize the entity itself. For instance, I don't know, the type car suggests that the entity will have attributes like speed, location, fuel level, and so on. And each attribute have its value, that is the current measurement, or we can say the state at the time of an attribute. So then our context broker instance is deployed on a specific URL, of course, a public URL that is the base path of our context broker. And starting from these, a set of APIs can be hooked up and they provide functionalities to generate, to manage the data. We have the classic CRUD operations that are, of course, REST APIs that allows to create, to read, to modify, and to delete the data. In particular, for the context broker, we can create entity by entity with the post request, but there is also the possibility to create at one time a set of entities. Then we can read in many ways the information. We can query the information inside the context broker by using, for example, a simple get by specifying the ID of an entity, or we can query by type the entities, or we can read in different ways that I will show you later more in detail. At the same time, we can modify the content of the data. In particular, we have many functionalities in order to modify, to update the data. We have the simple put operation that receives the entity ID, but there is also the patch operation. The context broker supports the patch operation through which it is possible to basically update in block a set of entities. I can say that these functionalities could be very useful in managing huge context information, a huge amount of data in our context broker, and so on. At the same time, we can delete entity by entity and then delete in one time many entities in our context broker. So here we have many examples for the various type of functionalities. For example, for the creation of entities, basically an external third-party application can create a new entity in the context broker by using the specific API, and can create the entity with the set of the attributes, or create multiple entities with a single request, as I said previously. Then we have the functionality of update to update the entities so that an application can update also a single attribute of a given entity with the specific request. Then can update all the set of attributes related to the specific to a specific entity, and attributes can be also added to a given entity at any time without the need of reinitiate the entity itself. Of course, the most interesting functionality, the most interesting operation of the context broker is the possibility of querying the data, which allows us to make inferences on data by specifying basically conditions on the information we want to obtain. For example, we can query for a specific value of an attribute or query for the values of the set of entities of a given a set of attributes of a given entity, and I will show you later how we can query the context data by using specific conditions and filters, but also operators. In particular, with this query functionality, the filters are very useful to customize queries and obtain we can say the desired data. No, filters are represented as parameters in the URI, in the URI, and except when, of course, we are using a post query. This is the case of the geo query that I will present later, and also other type of queries. For example, the query where we are specifying a set of attributes with separated by the comma, where we can by specifying a set of attributes comma separated in a comma separated list. And when, for example, we would like to query by language to select the language to use using the language property. So